Hello, welcome to Introduction to Java Programming. In this session, we will discuss about the exception handling mechanism in Java with the help of the keywords try, catch, throw, throws, and finally. Let's begin. So we understood in the previous session what is exception, what are checked exceptions and unchecked exceptions. And now let's understand how to handle when an exception occurs. In order to handle, Java has provided us 5 keywords: try, catch, throw, throws, and finally. So out of these 5 keywords, try is a block, catch is a block, and finally is also a block. And throw and throws are just classes or statements. And what should be there in a try block, or what is there in catch or finally, let's understand. So try block is a block which is going to contain the code that might throw an exception. Okay, it is to enclose the code that might throw an exception, that may throw or may not throw actually. But whenever we feel there is a possibility of exception, then that we have to keep in the try block. Okay, so try block is used to enclose code that may throw or that can raise some exception, right? That is the purpose of the try block. Okay, so whenever you write the try block, try must be followed by a catch. It must be followed by a catch. So if it is a syntax of catch, catch takes an expression. So here some expression is some expression we have to write over there. That expression usually the exception object which is thrown in the try block. So the point here is try must be followed by a catch, and catch take an expression. So that is nothing but an exception object. It takes an exception object. And here we will be writing the handling part. We'll be writing the handling part. So whenever exception is thrown in the try block, it will come to catch block immediately. And here the handling part has to be written. So what are different ways of handling actually? The handling is just reporting what the error has happened. So we will usually what we do is we are going to print that particular error, whatever the exception object that is thrown, we will print that particular exception object. System.out.println e.toString will come, so it will tell about the exception that has thrown. Okay, this is one way. Otherwise, we have a method actually that is called print stack trace. So we can actually use like this. So e dot print stack trace. Okay, so this method actually prints the whole of the stack trace. That means in which method the exception has occurred, in which line, and that method is called in which other method. So all that information is going to be shown with the print stack trace method. So this is also kind of reporting only. So usually in the catch block, what we do is we just report errors which have happened. We report exceptions which are thrown from the try block. And lastly, we can also have one more thing. So we can write something like this: system.out.println, and we can say e dot get message. So each exception has some description of the description. So that we call as exception description or error description. So each exception is associated with certain error description, and that description is going to get displayed with the get message method. Okay, so in the catch block, you will either write a code to print the exception object, or you will print the stack trace, or just get the description of the exception. For example, arithmetic exception has occurred. Now you will see the description as divide by 0, right? That is about the catch. So try must be followed by a catch block. And there is a finally block as well. It's a block. It's a finally block. If at all you are writing the finally block, it should follow the catch. It should follow the catch. So finally must be followed by catch. If you are writing try, catch, and throw, I will tell you that sequences actually. But what actually is the finally keyword is about? What we are going to write in the finally. So finally block is the block which is always going to get executed. So this block always gets executed. always gets executed in the sense whenever you write finally block, whatever you write in the finally block is going to get executed whether exception occurs or not, whether exception handled or not. The finally block is always going to get executed. So what we write usually in a finally block, that means your program may be getting crashed. So before it getting crashed, right, and this finally is going to get executed, and you may be handling the exception, that time also this finally going to get executed. So usually what we do is since it is going to get executed whenever exception occurs or not, we write certain cleanup code, actually a cleanup code or some important, so important things to be done when something is going wrong, right? So those important things we actually make up over here in the finally blocks. I will tell an example with the finally with certain resources. So usually what we do is, if at all we are using any resources in our code, if at all we are using any resources in our method, because code is method only, right? So this your try block or catch, everything will be part of a method only, right? If at all you are using certain resources like file streams or some readers streams, reader streams or writer streams or databases or network streams, these are all the resources. Whenever you are using resources, we will actually close them. We'll actually close them in the finally block. So before it gets abnormally terminated, at least those resources will get closed, actually. Okay, so resources closed stuff that we are going to write in the finally block, right? So this is these three are the blocks, actually. So if at all we are writing, these scenarios are possible. So you can write try catch, that is most commonly we write, and you want to add finally, we can actually have try catch finally, and we want to omit catch, and we can also go with try and finally. Okay, so these are the possible scenarios. So try must always be possible either by catch or finally. So try can't live alone. So whenever you write try, it must be followed by a catch, or it should be followed by finally. So if you want to write all the three, then the sequence will be like this: try, then catch, then finally. So you cannot write try, finally, and catch. So try always, if we write catch, it should always be followed by try. Then finally can come. So these possible scenarios: try catch, most common scenario, and then finally also we can add. If catch is not there, we can actually do with the try and finally also. Okay, so coming to the throw and throws. Throw actually happens implicitly for all Java API exceptions. So for example, here in the code in the try block, what happens here? So that code, if it has potential to raise an exception, so it will throw an exception. So throw keyword will come implicitly. Throw new whatever the exception that is actually going to get thrown. So like that. So it will happen implicitly. We need not to write this. Whenever that scenario comes, right? For example, null pointer exception comes, or arithmetic exception comes, number format exception scenario comes, automatically that exception object is thrown. So it will be like this: throw new exception followed by the constructor. So an exception object is thrown. So by using throw keyword, an exception object is thrown. When it is thrown, where it will come? It will come to the catch block. In the catch block, we are going to handle here. So we will catch that exception object. We are either going to print this exception object, or we will print whole the stack trace, or just a message error description we are going to print. Okay, so yeah, that's about throw. And throws is actually to declare exceptions, to declare exception classes. So what is for throws means? It is to declare exception classes. Whenever a method has the potential to generate an exception, it will declare. I have inherent capability of throwing this exception, and it will declare it. So to declare exception classes, we use throws keyword. So of course, we all understand all these things one by one. So before actually going to discuss about all the keywords, let's first understand the essence of exception handling. Okay, let's see a scenario where you are not enforcing the exception handling. That means you are not using try, catch, throw or whatever it is, and what is going to happen. And when you enforce exception handling, that means when you use try and catch, what is the difference? Let's understand this important thing actually, right? What is the use or what is the benefit of exception handling, or what is the benefit of handling exceptions? Let's understand. So in this scenario, what I'm doing is I have a scanner which is used to help me to read integers, two integers, and these two integers I am taking them into A and B. And later I am doing a simple arithmetic. So I am doing A plus B and I am printing the sum. I am doing A by B, printing the result, and I am printing A into B and printing the product. And let's assume there is some other code also. So this is the scenario, okay? And I have not used any exception handling mechanism keywords, no try, no catch, etc. Let's see what's the issue with this particular code initially. Okay, so let me compile this. This is exception demo, Java C exception demo.java. Okay, so it should get compiled successfully. It's taking some time. Yeah, it's compiled. Now when I run, it asks me about two numbers. So I'm not actually asking the numbers, right? So I have to give the numbers. So because here I didn't mention a code to enter two numbers, but I have to give two numbers, 1 2 3 and 3 2 1. 1 2 3 and let's say 12. Now I will get sum equal to 135, result is 10, and product is 1476, and rest of the code follows. But here let me ask also to enter two numbers. That will be easy to understand. So enter two numbers. Enter two numbers and I am going to read it. So this could be fine actually. Okay. So now let me compile again since I have changed the code. Yeah, compilation is taking a bit time. Yeah, it's compiled. Now let me run Java space exception demo. Now it asks me enter two numbers. Okay, let's see the scenario here. I am giving 15 and 4. So now sum is 90, result is 3, product is 60, and of course rest of the code is there. So this is working fine. Now let's observe for this scenario. Now what I'm doing is enter two numbers. I am entering 10 and 0. 10 and 0. So now sum equal to A plus B, right? So that will be 10 will get printed. Then A by B, 10 by 0. What is 10 by 0? Whenever you divide by 0, what is going to happen? Arithmetic exception. So divide by 0 is not possible because that is infinity. Integer division has infinity and there is no representation for that. And that's going to be system crash. That is going to be system crash. You are asking for A by B where your B value is 0 and that is infinity, and system could not able to identify what is infinity, and system simply stops, abnormally terminates. So line number 14, you have a big issue actually. And since there is an issue in the line number 14, none of the things will execute after this 14. Let's now see. So here sum got printed because 10 plus 0. Then actually when you come to the line number 14, so it's clearly telling exception demo.main, and line number 14, you have exception in thread main, java.lang.arithmetic exception. So this is actually the exception class, and this is the exception description, divide by 0. The get message thing is there, no? That is actually divide by 0, and this is the exception class. The object thrown is of this particular class, and this is the result. So why actually we are doing divide by 0? Divide by 0 results into arithmetic exception, and here it abnormally terminated. From the line number 14, it got terminated. So none of the things are getting executed. So as if you are flying on the plane and some problem occurs and your plane crashes. It doesn't land actually because it's a crash. So here it's a system crash at the line number 14, right? So this is the issue actually. So what has happened here? So java.lang.arithmetic exception is thrown. arithmetic exception is thrown. Okay, so are we catching? Are we enforcing any exception handling? No. So here what happens implicitly, throw new java.lang.arithmetic exception. This object is actually thrown and we have not enforced any exception handling over here. No try, no catch kind of stuff. So that's why from this instance, none of these things are getting executed because it crashes this from this particular point. It abnormally terminates. Right? This is what actually is going to happen. This is a logical error, right? So the developer has to take care of these things. Whenever you are doing division and you have to see that your B value cannot be 0, right? So now same scenario, now I am going to enforce exception handling. Now we know that there is a try block, there is a catch block, and finally throw and throws. Now we have to use or we have to enforce exception handling over here. So what is the problematic code actually here in this main method? So the code that may throw an exception is this. That may throw, right? So whenever B value is 0, then only exception is thrown. Otherwise, it is not throwing any exception. So this is the code I want to keep now in try block. So I'm enforcing exception handling. Let's see what happens now. So try, and I'm closing my try over here. I've started my try block and closed my try over here because this is only the problematic statement, right? So int result equal to a by b, and if goes fine, then I will print it. If it is not going fine, so I have to come out because when it's something wrong, definitely this line is not going to get printed. So these two lines I kept in my try block. So this is the code where I'm anticipating an exception, right? So if you write try, what must be there? A catch must be followed. So catch and takes an expression. And what catch has to, what should be there in the catch expression? The expression that is thrown. So the exception that is getting thrown actually. So here in this scenario, when I'm saying a by b, so arithmetic exception object will get thrown, right? So that's why what we are doing, we are catching that arithmetic exception. And because I'm catching an object, I need to give a reference to that. And here is my catch block. So usually in the catch block, what we do? So I'm saying e dot print stack trace. So of course we have different things. We can actually print the object. Otherwise we can actually print stack trace. Otherwise we can say e dot get message also. Now what I'm doing, I'm actually using print stack trace. So whole of the things are going to come. So that means which method and which line the things have gone wrong, all that information. So this is what enforcing exception handling. So now what I did, I have enforced exception handling. Okay, so whatever the code which is throwing me an exception, I put that into try block. So I am enforcing exception handling now by writing try and catch. So try and catch is there, and I'm catching the exception that is getting thrown over here actually. Whenever b equal to 0, definitely arithmetic exception is going to get thrown, and I'm catching that and I'm printing this, right? Yeah, so now I have enforced, and later my code continues here. I'm not having any changes to this. Now let's see when you run what is going to happen. Now understand the essence of exception handling now. So now let me compile this java c exception demo.java. Now I have the code with the try as well as catch. Okay. Yeah, it's taking some time to get compiled. Let's wait for that. Yeah, it's compiled. Now let me run. So it asks me two numbers. Now I say 23 and 3. 23 and 3. There is no exception. Right? So a equal to 23 and b equal to 3, and there's no exception. Everything goes fine. Even though you have enforced exception handling, nothing is happening because 3 is not 0. So everything is fine. Now let me now see the scenario. Now I am giving 12 and 0. Now what happens? Arithmetic exception object will throw. Arithmetic exception object will get thrown using the throw keyword. And now we are catching with the catch block, right? So it should actually lead to abnormal termination. But since I have enforced exception handling, now what is happening? Let's see now here. So sum equal to 12, however, this will come. But at this instance, A by B, line number 14, sorry, line number 16, I have an exception. So java.lang.arithmetic exception divide by 0 at exception demo.main, and this one is happening. So this we are printing actually. So now you can see, observe here, there is no exception in thread main. So it's not abnormal termination. I am handling it and I am printing the stack trace over there. And since I have handled, my code continues over there. My code continues over there. See, it is actually printing me what is product, and it's actually printing me the rest of the code also. So that means what? You are flying on a plane, something goes wrong, still you will get landed. Still you will get landed. That means your program executes. You will allow your program to shut down smoothly, graceful shutdown. That is happening because you have try and catch. So you saw the difference between previous and now. Before exception handling, it abnormally terminates. Nothing from that line will get executed. But now that part is not getting executed. So line number 16, 17 are not getting executed, but your rest of the code is getting executed. So that means you are in irctc.co.in, and there are so many things. You can register, you can check your PNR status, you can book tickets, you can do the payment, right? One module is not working, but all others are working. That means your application is still there. It's not getting vanished. It's not getting crashed. But that part is not working, but rest all are working. And you know that why other part is not working. So that means you are get notified with what is actually wrong. Fine. So this is the essence of exception handling. If you enforce exception handling, if you use try catch, still you are into the program, even though something goes wrong, right? So this is actually a beautiful feature in the programming languages. Okay, so coming to this catch block. So here I can actually say something like this also. System dot, okay, let me write here, PL, system dot out.println, we can say, even we can also say error.println. So we have error stream also. We have error stream also. So I'm printing the object over here. So we have system.in, system.out, and system.error also. If any error we are printing, we can actually use system.error also, right? So it just gets print like normal output only, but it is defined for errors only. So now let me compile this. Let me compile. So rather than printing stack trace, I am printing just the object. So now it is going to print us just like java.lang.arithmetic exception. Let's see. Now I will make a scenario for arithmetic exception. So I am giving 23 and 0. Now arithmetic exception is going to come. So now you can see sum got printed, then java.lang.arithmetic exception divide by 0. Okay, so now when what is happening here? So whenever a by b, now implicitly throw is getting called and it is throwing new arithmetic exception object. From this place right away it comes to the catch, and we are catching properly. We are catching properly with the same exception, and we are printing this e, and that exception object is getting printed. So that is nothing but java.lang arithmetic exception. And since we have handled, the other parts of the code is also getting executed. This other part is also getting executed, right? So this is the essence of exception handling. Okay, so in this code, of course, we have the potential for potential for other exception also. So what is that exception? Okay, so in order to tell you that, I just make few changes to this. I will bring this particular sum also after my division. Okay, so now what I'm going to do is these lines actually. So where I'm expecting the potential for exceptions is here. Okay, so there is a potential for exceptions in these two lines actually. So now what I'm doing, I'm keeping my try block over here. So try, and I have these two lines, and these two lines have the problem actually. I will tell you what is the problem with those two lines. And of course, a by b has a problem again. Okay, so now let's understand. So what is the problem with these two lines? So what I'm doing, I'm reading an integer over here, right? I'm reading an integer and giving to my int values. So what if user gives string? What if user gives string? right? I am asking for enter two numbers. What if user gives me string? There is a problem, right? There is a problem. I'm asking for two numbers, but user gives me a string. Okay, now let's see actually. I kept them in try block. I kept them in try block and try followed by catch, and I'm catching arithmetic exception only, A by B only. But now there is a problem with this particular next int methods whenever I'm reading the values. Let me actually show you that. Okay, so now let me show you this by compiling. So scanner, I am reading integers using next method. Now, what if user enters? What if user enters strings or some other values other than integers? So that's the point we are going to understand now. Yeah, so there's a problem actually here, compile time error, because I kept a comma b in my try block. Now see, I kept my a comma b in my try block, and after try block I am using a and b, right? So when you declare any variable, in a block, the scope of those variables are within that block only. The scope of those variables are within that block only. So now I am actually declaring my a comma b outside. Yeah, since I declared earlier here, I cannot access them out of that particular block, right? So those are local variables, right? Yeah, that's why that problem. And yeah, so now let's compile again. Now I have declared A and B outside, so I can use actually them throughout my program. They are not confined to any particular block. Okay, so yeah, now let's see. Yeah, it's compiled. Now, when I run this, it asks me two numbers. Now, I am expecting numbers actually. That's why A and B are integers. But what if somebody gives like this 10 and 5? Somebody gave 10 and 5. Is 10 a number? No. Next int, and I have to give to an integer. It is possible? No, right? Now, let's see what is the problem. So, you are going to get abnormally terminated, because this you are not handling. Even though you kept in try block, you are not handling this exception, that is java.util.input mismatch exception. Java.util.input mismatch exception. Whenever I give 10, what happened here? This line number 9, you can see the problem is at line number 9. So whenever I say next int in.next int equal to a, 10 I cannot give to integer a. And I cannot read also using next. So it's actually java.util.input mismatch exception. So if I give this a number, and at this line there will be an exception, right? So these two are vulnerable points actually. Okay, so now what we need to do actually is we need to catch that. So for that, so I will say util.start, because I am going to use input mismatch exception in my program. So that is there in util package. So import java.util.start. So my scanner will be there, and I can actually do with my input mismatch also. So now what I do here, so here there is a potential for what? Java.util.input mismatch exception. Input mismatch exception, right? So here also same thing, right? Here also we are going to get the same thing, input mismatch exception. Now I kept in try, but I have to catch it. So first I am doing arithmetic exception, and I am catching next now. I'm catching now input mismatch exception. So now I'm writing here input mismatch exception. E, and here I can actually say system.out.println E or system.error.println. See, now I am writing multiple catches. Why I am writing multiple catches? Because my try block has the potential of generating input mismatch exception if my input is wrong, or arithmetic exception. So of course only one exception happen at any time, because at this instant exception happened, you will come out of the try block. So if they are fine, at this instant exception occurred, and we will come out of this particular block. So now when it comes over here, I need to catch arithmetic exception. So when it comes out of Well, the first thing I have to catch mismatch exception. If this happens, then I have to use arithmetic exception. So you can write in any order. When exception occurs, it will come out and checks whether it is matching. It handles it. Otherwise, it goes to the next catch. So at any time in a try block, only one exception occurs and only one catch is going to get executed. Fine. Now let's now see by compiling this. Now let me compile javac exception demo.java, where now I have written the catch block for input mismatch exception also, because there is a potential. There are two lines where input mismatch can happen, right? So a try block can be followed by multiple catch blocks. Since a try block has a potential of generating multiple exceptions actually, but at a time only one catch, only one exception will be thrown and one catch is going to get executed. Now let me see now. The first value I'm giving 10, so that means A is fine perfectly, right? Second value I am giving 10. Second value I am giving 10. So that means at the line number 10 you have a problem. So immediately you will come out. Immediately you will come out. And here arithmetic exception is actually what happens? At this line number 16, throw new java.util.input mismatch exception, and it will come to this catch block. It doesn't match, so now it propagates, and here this one matched. Since this is matched, it will print E. Since we are providing handling, the rest of the code is also getting printed. Now let's see. So it's not abnormal termination now. Since we have handled it, it's not abnormal termination. See here, enter two numbers 10 and 10. So line number 16 error has occurred, but I have handled over here in the catch, right? Since I have handled, my rest of the code is also getting executed. So that's the essence of exception handling. Now let's see the other scenario here. Now this time what I'm doing, I am giving both the values fine. I will give both the values fine here. So I will say 10 and 0. So that means input mismatch exception will not happen, but A by B will happen. So I will have arithmetic exception. But since I have handled it, it works fine actually. So rest of the code is also getting executed. So this is the essence actually. Now, so one last point I want to tell you. So here I'm writing multiple catches. So I can actually write a single catch only. How I do is, so if I'm not sure of what exception is going to happen, and specifically I don't know what exception is going to come, I can always catch with my super type. Now what happens, since it is an exception is a super class of all other exception classes, right? Whether it is runtime exception or a checked exception. So parent classes can refer to their child class object. So whatever the exception happen, whether it is input mismatch or arithmetic exception is going to catch that. So like that also we will write. So let me compile and show you this so that we can conclude this particular thing. So javac exception demo. So what I'm doing here, I'm not writing multiple catch blocks. I'm writing only one catch block with my super type, because whatever the exception occurs in the try, this will match, right? Whenever that exception is matched, we are printing that. If input mismatch, and that is going to get printed. If it is arithmetic, that is going to get printed. So now let's see. So now I'm saying 12 and I'm saying 3. Now input mismatch exception, now you can see here input mismatch is handled and it's getting printed. Rest of the code continues. So this time I will give both the values fine, but it is 0. Now arithmetic exception is going to come, right? So you can always use your parent type to point it when you are not clear about the specific exception, right? So this way we can actually discuss many things over here in the exception handling. So as of now, this session focuses mainly on try and catch. Okay, so in the coming session we will add finally also, and we will also discuss about throws, declaring exception. So hope you have understood this, and basically the essence of exception handling, what is happening if you are not enforcing exception handling, and what is abnormal termination or a crash, and what is going to happen if you enforce try catch. So how your rest of the code is getting executed, right? So if you understand this, then you are good to go with the next parts. Okay, hope you understand, and see you in the next session. Thank you.